All right, doing one more of these. Okay, my A value is going to be 2. And that's going to be the coefficient of x squared. And B is going to be negative 12. That's going to be the coefficient of your x. So finding the vertex. Using your formula, negative b over 2a. Now this time, since my b is negative, I would have negative 12, which will end up being positive 12, and I'll just change that in the next step. And then I would have 2 times 2. So positive 12 divided by 4 will give me 3. And now I take the 3, substitute it back into the function. Okay, so let's see what we're going to get on this one. Maybe a little large, but that'll be all right. Let's see, 18. So I get negative 15. That's not real bad. Okay, now axis of symmetry. So that'll be located at x equal 3. And last, y-intercept. And if it's a y-intercept, you're substituting 0 in for x. So that's, you already know what your x coordinate is. So if I substitute a 0 here, that term is 0. Substitute a 0 here, that term is 0. So therefore it leaves me with just my constant of 3. Okay. 3, negative 15. So you're going to need a good bit of space down your y-axis, because your y value is negative 15. You don't have any in your homework with numbers even that large, but we can make do. It'll be fine. Okay, so I'm going to go down 15. and 15. Now you don't need many tick marks going out the other direction, so just do a few for those. Okay, vertex is at 3, negative 15. Go ahead and dot in again your axis of symmetry. Okay, your y-intercept is located at positive 3. All right, so now we need to get the point over here on the other side, so reflecting this point. So this time the distance from here to here is a distance of 3, so we need to go 3 on the other side. So here's my parabola this time. Okay, so have a little bit of a bigger number there, but not a big deal. Again, I know the ones in your homework, you don't have numbers that are even that big. All right, one more problem, and this is actually a word problem. So first of all, you might want to pause the video while you copy down the word problem. All right, the model for the performance of a stock, so this is like trading stock, is P equals negative 3D squared plus 50D, where D represents the days of trading and P is the price per share. What is the maximum price per share of the stock? Okay, now I know when you say word problems, and I know word problems can be hard, but this is not a big deal. Actually, this just boils down in the bottom. What you're dealing with is vertex, okay? Because anytime that you're asked to maximize or even minimize, you're actually dealing with the vertex, okay? I don't know if I still have Like the note that I had given you earlier, actually in the previous section, this one, where I'd sketched off the parabolas the first time for you. Of course, in this case, when your parabola opens up and your vertex is at the bottom, this is actually a minimum point because this is the lowest point on your parabola. So that's referred to as a minimum point sometimes. If your parabola turns down and your vertex goes to the top, then that's referred to as a maximum point because it's the highest point on your whole graph. So any word problem that you run across when that's a quadratic, of course we know this is quadratic because it's got the second power, but you're asked about maximizing or minimizing, your answer is going to come from the vertex. So that's all we've got to do here to answer our question, is just come up with the vertex. Now I'm going to rewrite this function here. Of course, all of them that we've been doing so far have been in terms of x's and y's, and we've got a p and a d here. But if it helps you make sense of this would be the same thing as y equal negative 3x squared plus 50x. You know, just to help you keep track of what's what. You could rewrite it in terms of x and y if you choose so. Now, it wants to know what is the maximum price. So, of course, price is P, which means you've got to come up with y. Well, if this maximum is going to be at your vertex, you need the y coordinate of your vertex. But before you get the y coordinate of your vertex, you have to get your x coordinate. So let's start out with finding x, which is equivalent to the d. Remember, x and d are interchangeable here. So that's using the negative b over 2a. All right, so my b value is the 50. And a is the negative 3. Again, you could look at it here in terms of x if that makes it easier for you. All right, so that's negative 50 over negative 6. Now, if you want to change that to a decimal, you could. Let's see, that's going to be a repeating decimal. So let's just leave it in fraction form. Let's go ahead and reduce it though. So of course you could reduce by 2 and you'd have 25 over 3. Okay. Now, like I said, this is the same thing as 8.3 repeating, which if you were asked about number of days, it would be a little over 8 days. Okay, but the question is the maximum price. So we need P. So let me come down here. P, remember, is the same thing as Y. Now, when you're talking about your vertex, how did we always find the Y coordinate of the vertex? We had to take our X value and plug it back into the function. Again, I'm going to keep it in fraction form. So you would have negative 3 times 25 thirds to the second power plus 50 times 25 thirds. Now you can just use a calculator to help you out with whatever you need to, you know, as far as doing the calculations. All right, so let me put this in the calculator real quick and see what we get. Okay, I come up with 208.3 repeating. So P, remember, is price. So what that means is you could say that the price, if you rounded it off, would be approximately $208.33. I mean, if you're talking about money, you would round to 2 decimal places. So this is actually the answer that was being looked for here because it wanted to know the maximum price. Price is P, which is equivalent to the Y from the vertex. So like I said, it's just a vertex problem is all it is.